Hello. We are live. Welcome to the live stream. We're on day 2. Well, it's a discontinuous day 2, but it's the second day we're working on it. The electric motor out of wood, nails, and wire. Let's just take a look at what we have so far from last time. Hey everyone, how you doing? Good to see you all here. Gaming Mind Digger, Amin, Raid, Cookie, Jamie, Anton, Cameron. It's nice to see you all. So I got a few designs in. Let's just update this a little bit to show what we really have. Let's see, electric motor. We have the commutator housing. This is the commutator. No, this is the commutator. And this is not the commutator housing. This is the armature core, I think. Yeah, that's the armature core. It's the second half of it. And this is the commutator house. Oh, wait, it's the whole thing. The commutator. What is this? We're building a motor. That's what it sort of is for now. So let's see here. What am I doing? I'm building a motor. Not just any motor. It's gonna be the best motor. Out of nails. Can I duplicate this? I wanna... There we go. Need 4 of them. And then... Let's see, how did we assemble it? I have it here, because I printed it out. It's the model that I had yesterday. It's right here. So, it looks like... Oh, let's see. Can I change the music? Yeah, I'll bump it up. Alright, bump it up. I mean, bump it to the next one. It's really what I meant. Also, yes, Andrew, you're first. Congratulations. So let's see. This. We can mix these up. The mate. It's not exactly right. That way. It's kind of close. Let's see, how do we... need to lock the rotation too. Lo-fi. That is a statement. Let's... part. There we go. Put that up there. Wow, check it out. It's prettier. Now let's take this piece and mate it to that surface. And then this. I need that cylinder and this cylinder. They can be concentric. And then can this rotate at all? Nope. Alright, that's fixed. Now, do I remember you? Of course. How could I forget? Believe I have this like that. Alright. And we have one here. Boom. And boom. It's cool. It's like assembling it. Alright, so we have that. And now we just do the other side. the other direction. So this way. In the other alignment direction. And move it down. What? Move it. Oh my gosh. Where'd it go? Pull that up. In. There we go. Boom. Oh, thanks, Amazing Enthusiast. I appreciate that. Oh, yeah, my mood. Hey, Razix, how you doing? Nice to see you around. We're continuing with our design. We're assembling what we have into the software. It is going okay. It's a little derpy. Oh, there we go. Yes. Okay. Wait, what? Oh, I think I used the wrong nail. Oops. No, I definitely have the wrong nail. Oh, it's Control-Zing a lot. I didn't press Control-Z that many times. SolidWorks, please. Alright. You just Control-Z all the way to the beginning? Can't redo. Alright, maybe I saved. Open recent. Wow, close. Without saving. Oh, that's a little obnoxious. Alright. Alt F4 to redo. I would, you know, I don't know what happened. That's great. Oh, no, not the STL. SolidWorks, please. Oh my gosh. Alright. Alright, SolidWorks. This is A-okay. Everything is alright. What's my major? Mechanical aerospace. So nothing to do with electric motors, but you know, still pretty cool. Alright. So let's start over, I guess. That's fine. It took like 5 minutes. A-okay. So we have the commutator, 2 armature cores. We align these. We should like went a little faster because the mating animation is really laggy. I don't know why it's so slow. I'm like not doing anything. Wait. You just created the mate like that. Okay. Let's try this again. Reverse. 2. And then we have 3 if we select these 2 faces. 3 mates, and that locks it. And then this one goes to this surface. Yeah, that's fine. That works. Boom, boom. Alright. So now let's exit this part, save. So I don't have to do that again. I'm thinking of adding computer science to my major list as well, but I don't know yet. Hey Lawrence Martino, how you doing? Maybe I should do this one. I think it doesn't really matter. That surface with, oh my gosh. Okay. That surface. Boom. Actually, I could do a couple mates at the same time. Is this concentric? It is. Undo. Undo. Undo, undo. Alright. So, I think I want to duplicate this a couple times. I need like 4. Wait, where are the other ones? What? Oh wait, did they all paste in the same place? Oh, they did. Cool. So why did I design inspired from Wintergatan? Not really. I mean, they are inspiring, don't get me wrong. I decided to do it this way because I'm 3D printing some of my parts. I might as well assemble it in here while I can. Just cause like whatever, right? Alright, so let's do that, and let's do a triple mate. Boom, boom, and boom. Wait. Why would you do that? Why? What? Okay. That was strange. Yeah, I'll just do them one at a time. It was really weird. Whatever. I tried to make it fast, okay? It didn't work. Get in that. Get in there. Flip. Oh my gosh. Come hither. Boom. Alright. And now we should be on our last one. Again. SolidWorks and fast don't go together. Yeah. It's a little slow at times. There we go. Now we have our armature core completely built. Now. What do we do? We can grab the big nail and stick it through. Perfect. There we go. Okay. Then what? I need to design another part for the electromagnet at the bottom. What's up? Well, we're building a motor. It's very exciting. Somewhat. It's somewhat exciting. I don't know if I'll even use these nails. Don't know if they have any purpose. I might fix this just so I don't have to keep picking it up separately. Let's see, how are we gonna do this? Let's mate these two. Distance. Let's say 2 inches. Oh, that's too short. Like 2.5 inches. Oh my god, SolidWorks. Typing. That's fine. That looks okay. We can change that later. Okay. So now we have this. We can put that right over there. Also, Lewis, thank you very much. What's my favorite mechanism? My favorite mechanism. Pulleys are pretty cool. Then again, so are levers, for the same reason, in my opinion. It's just increasing output. It's really cool to me. So let's see here. The way that this is supposed to work is I have to have these pinned down into the board, and then that holds this in place. but I also have bearings. So I could just use these to hold down the bearings. We can do that later. But for now, we need a core of the electromagnet. We'll have some of the big nails for that. Where are they? Well, more of these nails. So the spec is that it's bent in half, and the heads are spaced 3 inches apart. How long is this? This is 4 inches. The spec says the heads of the nails 3 inches apart. Are they sure that's what they want? Because that's 2, if that's 2 and 2. Oh, so it'd be jutting out like a 1/2 inch. That's interesting. Oh, because this is like 2 inches. So 3 inches would be enough clearance. Okay, I'm just crazy. So we'll make a new part. What am I gonna use the motor for? It is a school project. So the tolerances that I used for this were like really good. So let me open my commutator after closing this, so I can check the diameter here. That's the one I want to really use. And that looks like 0.16. Okay. Copy that. Copy that. This, what? I discard. Wait. In a sec. Oh, wait, that's the new part. I didn't want to close that. What keyboard is that? This is a DAS Keyboard Pro 3 with custom keycaps. I put them on. They're white and pretty, and there's a paw. It's a paw. It's a paw key. I don't know if you noticed, but look, it's a paw. Hey Riku, how you doing? What's my most favorite event in history? Wow, that is a very broad question. My favorite event in history. I don't know how to answer that. I'm not a very history person, but if I had to say, Halloween's pretty cool. Anyway, let's extrude into the front plane, or out of the front plane. We're gonna have a circle, and we're gonna have 2 more circles, and we're gonna have a midline, from construction, and then merge.
Oh, yes.
Here's money for McDonald's. Go get me a 20-piece McNugs.
Thank you, Riku, for the $5 super chat. I will certainly get a $5 McNugs. I'll send you a picture too, just to prove it, because it's important. You need to know where your money's going. What was I doing with this? This is a electromagnetic core. And then these two is 0.16. in diameter. So 0.16. And then this should be, this should be equal to that. Text to speech, so yeah, absolutely. By the way, seriously, thank you, Riku, for that. Really helps. Okay. So I could dimension this. Did it substitute? I think I'm sub to PewDiePie. 0.15. It'd be kind of a pressy fit-ish. Let's like try like 0.155 just because fitting, you know how that is. And then I want like a radial thing here. So let's do this. And we want like 1 or 2 layers out. So let's look at what we did for the outer ring on our commutator. Oh, it starts with this. Okay. So I need to open this one. My neck is now a noodle. What? So let's take a look at this. Okay, so we put a distance of what is this? 0.4 inches? 0.04. Okay. We could probably use about the same here. So let's go back here. This can be Ujiko song in the background? No, it is a Syntheon song. It's called Compito. 0.04 inch. Gives us a pretty good profile of that. It's like half the thickness. It's about right. Realistically, the diameter of this can only get better. Let's see. Do we want more nails in the core? Because I could do that. Here, where's let's see here. Okay. Oh, you're not distracting me, don't worry. So, I don't know. You're relaxing? Oh, it's relaxing. Yes. It's pretty chill here. Let's see here. Let's see here. Do we want to make it bigger? Like, it doesn't matter, right? We make it like 0.1 inches. We could add more to the core if we wanted to. A bigger area would increase the induced current. What it? Wait. induced magnetic field. Wait. So current around this way induces a magnetic field. That direction. What are we talking about? There's a current, so increasing the cross-sectional area will increase something. Although I have a lot of wire, so I could just make it small and wrap it a bunch. Let's see here. Um, 0.05. Well, let's have to go with that. Probably doesn't matter that much. I'm guessing. You never know, but maybe it doesn't. So let's extrude this. How long do we want to extrude it? So the nails should be like 3 inches apart. So we'll make it like, there's gonna be a bend, and that's gonna give some dimension. So I'll just make it like 2.9 inch. Although realistically, this is like 2 inches, right? Oh, this is 2.7 inches. So 3 inches apart. Okay, that's pretty close to 3 inches. So, and then we have what, 2.9. 2.9 is gonna be about there. So make it 2.85, then the nails will have about. That should be good. That's the great thing about designing these, is that you can make them a lot more exact. There we go. So that's how long it's gonna be. It extruded backwards. That's the core. Now how are we, the way that I want to fix this. Hey Dramavian, glad to see you in the chat. The way I want to fix this to the board is I plan to, although this might complicate things somewhat depending on how we do this, is to extrude 2 little, let's say, slots for zip ties, so I can zip tie it down. Or I could actually zip tie it onto here. That'd lose some length. It wouldn't be that big of a deal. Because if anything, I'd kind of worry a little bit about like the structural integrity of the plastic here, plus printing it like that would be suboptimal if I were to just make curves here, or even just secure it as is. Like I don't need to print in grooves. That could be cool. Let's see. Because I could just extrude out little pegs, but that means I would not be able to print it upright like this. Although, thank you, Jared. Good night to you. I think that this is small enough to where I can print this way, without the middle being too impacted. Also, I definitely want more contact in there, so let's just let's make these two semicircle arcs. So that's completely open. We just have a slightly press fit inside, and then we can just select this contour, and then we'll still be good. Now it's a big slot. Okay, and now that it's a big slot, How to secure it. Because this part has to be somewhat open because the nails are going to be curving upward from there. So, in some sense, I'd probably be better off just building a small hold there. And it shouldn't be too weak, I don't think. Because there's not going to be a lot of torque on it with such a short lever arm, as long as I put it close to the surface. So let's try that. And then I would just have to print this in 2 halves, which is not a problem. I'd probably want to do that anyway for a taller part like this. So let's sketch un circle. Confirmed lyrics is the smartest furry. I don't know, there's some pretty smart fellas out there. Oh, let's do midline. And a big trim. Set some constraints. This should be what? I want to select the circle. This should be co-radial. And this should be coincident with that. Or collinear. There we go. And now we extrude. Now, how thick are these zip ties? Oops. I need to know that. Zip tie. These are the ones from Prusa that I got with the 3D printer. So it's about 0.1 inches. So that's probably about how long I want to make it. Like 0.1. Oh wait, that's really short. Oh wait, no, that seems about right. And then I'll make it longer, like 0.25, quarter inch out. Okay, now that's really long. I think 0.2, half the width of the zip tie should be enough. Program, this is SolidWorks. It's an industry standard. Alright, so the nail can still come up just fine, and then I can zip tie to secure it snugly. So let's see, where is my front plane? So that's the front plane. I actually want to do something different here. Instead of going blind with this extrusion, I'll try going mid plane so I can use that plane as the center plane as well. So if I go like that, then that should shift everything and I should have this in the middle. Which then lets me mirror this. Mirror. I didn't want to mirror that. I want to mirror across this feature. There we go. So now we got that, we can secure the zip ties in place. Although, I could add like a bit of a cut, somewhat, so just to keep it secured. So it's somewhat recessed. I could just edit that from here. So it would pretty much would look like this. So as I move this, they should stay aligned, which is exactly what we want. And how tall is it? How tall is the zip tie? Probably not very tall. Like 0.0 something inches. So We can actually just dimension that here, and the rest should solve itself. Yes. Ha, geometry. Okay. So this should be like 0.05, let's say. Oh, that's really big. 0.03. Oh, when you watch me play Xbox in the pause? Yeah, that was fun. Big fun. What were we doing? Trim. Bop. Bop. Oh. No. I screwed everything up. Okay. Things have been screwed up. Oh, this should be construction. There we go. Then it makes things nicer. There we go. Let's see why I can't rebuild. More than one open contour? Does it? I see. Wait, is there like something imprecise? What? SolidWorks, I think you're going crazy. Alright. Let's see here. Show me. No problems found. Okay, then... Alright, so the SolidWorks thing said there's an error, but there are no problems found. But I also can't rebuild it. Thanks, SolidWorks. Alright, let's try this again. I don't understand what went wrong. Let's make these construction. Then we'll simply connect these. And then draw another arc, because apparently it didn't like ours, so... Alright, exit. There we go. So now it kinda... What does it do? It kinda rests against there. I guess it already kinda did. I guess that doesn't really accomplish anything. See, I guess what I was really going for... Let's roll back this mirror real quick. Was something to do here. I guess that's what this let me do. Because we can create this rectangle. That is not what I want. Corner rectangle. It allows me to create this one. I did not want it on the midline. And this length should actually be defined from the other side, because that's gonna be relatively like the width of our zip tie. So we want this one to be like actually probably exactly 0.1 inches. And I don't know about this line that doesn't want to stay in place. Collinear. Alright, and then we can extrude. Oh, you know, that's where I should have done the cut. That's what I should have done. My keyboard is a DOS Keyboard Pro 3. And good morning to you as well, Inugami. This is like less like 3D modeling, I'd say. It's more like I guess I don't know how I would describe it. It's like more technical. I think of like 3D modeling as more of like artsy. This to me isn't like super artsy. It's like not artsy. It's like designing parts and stuff. It's about like as not artsy as you can get, really. Alright, so let's revert to that real quick. And then we can sketch on our front plane here. Alright, and then we can draw a rectangle. Doesn't really matter where we draw it from, but might as well make it relatively right. Actually, it intersects the line, doesn't it? That's a plane. You're close. There you go. No intersection found for Pierce. What? I want that to... Okay, SolidWorks. I can't do anything to that face either. Alright, let's try this. Nope. Wait, so is that built with an error there? It's being a little difficult, isn't it? You woke up and I'm streaming. Yep, that's me. Yeah, CMCYT. You're not missing much. We're just chilling, you know. Remember to double check in the end because it's common to fail in modeling. Yeah. Using Autodesk Inventor. Yee. Okay, so let's start here. I should be able to make this collinear with the profile. Yes, okay. Now we're getting somewhere. Now I can't mate with the face. Okay. That's fine. Can I make these on the same plane? No, because that's a profile, of course. Okay, so it won't matter where this is really. So I'm gonna just make this up there. I kind of wanted to avoid that, but whatever. Please allow me to select this bottom line. Okay, normal. Normal. Still can't select a line. Rude. Just line. Just like a... Thanks, Little Flame. I hope you have a good sleep. It is 11:12 p.m. That's correct. Why is it not letting me constrain this? Why? Oh, that doesn't work. Okay. This is treated like a sketch. Oh, wait. Yes. Why did it let me select it that time? I don't know why, but thank you, SolidWorks gods, for letting me select that bottom edge. I can't do it again. I don't know how I did it, but we did it. Alright, now we want to make this like 0.11, I guess. Doesn't really matter. Looks like a little less than... Where's the zip tie go? Zip tie? Alright, I got another zip tie. So it's like 0.995, so it's like 0.1 inches exactly. I don't want to make it completely like bunk, you know, so I'm just gonna do that. Exit. No, don't exit sketch. Want to make a cut. That doesn't make much sense, does it? All right. So we want to start from an offset. Yep. 0.2. That. Wait, what? 0.5? Wait, why is it? Are the offset and extrusion direction the opposite? Okay, SolidWorks. Alright, let's try that again. So that's 0.02. That's pretty good. So 0.15. That's pretty good. Hey Ryan Paul, thank you for subscribing on YouTube. So that's pretty good. Gives a decent radius to grip. And so now we just have that little notch for it to sink into. Will it let me put that there? Yes. Okay. So now let's roll back this first mirror. And then let's show the right plane. Then we can mirror this cut across this plane. And then in this, we can include this cut and this mirror. And then I'll just do the same on the other side. For good measure, we could just do a bit of a fillet on those four. Just something subtle, you know. So let's make it like 0.05. It's pretty small. Well, that makes it rather recessed. 0.4. Because it still needs to be intact there. 0.03. There, it just makes it a bit prettier. Makes a little more sense because it's going to be a curvature when they're going to be wrapping down. So now I believe we have a pretty good part. So how are we going to do this? Insert feature split. Didn't really do what I wanted it to. Consume cut buddies. Do it. Oh wait. Well, I meant the other one, but this works too. Alright, so now we have a nice cut. Alright. Also, Little Flame, I'm really glad that you're able to get full marks for that. Yes. So now, we should just be able to load this into Cura. Let's export it first. Tremapian, I can't believe you're still hanging out here, dude. Hey, Soul. Why are you still awake? It's time for sleep. Alright, what are we doing? STL. 1, 2, 3. Here's our core. Big yes. We can undo that now since we're done exporting. And where's Kira? Here it is. And then what were we doing? Here, and then core, core, core. What? Like this. Oh, you almost got the rotation right. Oh, if I took the other half, it would have been right. Oh well. So basically, let's just rotate it 180 like that. Multiply one copy. Oh, look. Then we have two pretty things. Isn't that nice? Yeah, I'm going to sleep sometime tonight, so don't worry about me. Also, is it trying to build supports over the sides? Oh no. That's like the opposite of anything that I want. So let me just look at that. So it should. It's hard to get a good profile of this because Kira sucks at that. Well, I don't know what happened. Also realized I could just go down layer wise. Let's give it a look-see to see how far out it's actually extending. Yeah, that probably does need a support. But I don't need that much support. Don't connect support zigzags. I don't think that's it. Oh, support interface, I think, is what the problem is. So, oh wait, towers. I don't want towers. Yeet. Alright, so now there's just a tiny bit of support there. That's about what I want. So I have two of these. Put two of them together, and you get two of them. And the info for these probably doesn't matter. I mean, it could probably be 100. Like, let's see. If it's gonna take 1 hour to print these at the highest resolution, this seems like a lot of work for a couple of wind chimes. Thanks. Who would be my rival on YouTube? Rival? I don't think I have a rival. But wow, yeah. So that solid infill is gonna help make sure that the part doesn't snap right there. So it's like the only thing I don't want. It really doesn't matter what my layer height is. Like, I might as well just do it like that. And let us keep our settings. Theoretically, it will be a little stronger if I print it this way anyway. Thinking. What time is it? 11:24. Yes, these are wind chimes. My ultimate wind chime plan. I think I should just be able to hit print because I think everything's set up. So it's doing the crisscross. That's the good crisscross. What I'm gonna do with the electric motor, I'm gonna run it. I'm gonna get a good grade on it. because I'm gonna run it well. That's the plan. So now I'm gonna start printing these. Alright, so now that we have this model, we can take this in. What? Wait, what did I do? There's nothing. What? There's no current operation. What are you talking about? I'm not doing... Wait, why can't I move anything? Save? What? There's nothing. SolidWorks, you're just not letting me do anything. What? I can resize, but I can't close out of it. What? The close button is disabled. Wait, what? Is there another Wait, what window is this? Huh. I don't know what happened. Why did this come up? What? What? Has no contour geometry? Excuse me? It has some right there. Oh, okay. SolidWorks. You're so weird. Okay. Alright, that could have gone a lot worse. So, let's try to drag our core in. Yay! And now we can set the material here to be plastic. For some reason, I think it likes to be clear plastic. Wait. SolidWorks, what? What did I do? Okay, just made that go away. Thanos snapped that wood block out of existence. Let's make a bent version of this nail. So the 420, it's a 420 nail. Just noticed. Alright, so let's name this bent. So realistically, we'll have somewhat of a bend. We want it like right in the middle. So insert feature. Flex? I don't think I want to flex. Thank you, Garovat Adrian, for subscribing on YouTube. There should be one of these that lets me bend it. Although I don't exactly remember which one. I don't think it was flex. Let me see here. So, SolidWorks bend sheet metal. I think the process should be similar. Oh, insert sheet metal. Okay, so I don't know if the same rules apply here. I hope they do, though. So, bend. Can I bend this surface? It seems to be okay with it somewhat. Wait. I don't actually think anything happened. Alright, so we have to have a plane, which I guess can be the right plane. Doesn't really matter. Now, if I'm correct, I should be able to just like, well, let's first draw edge to edge, just so we have something to actually dimension to. Midpoint, sure. And then we'll draw a midpoint line from the midpoint here. I don't know if it'll like this, but let's try. What am I gonna... Alright, let's see here. Alright, sheet metal. Bend. And then, if we select this, does it work? Wait, I can't select it. Why can't I select it? See, I don't actually know what I'm selecting here. Non-planar face is invalid. Okay. Oh, wait. I kind of get it now. It's... Okay. Let's do something strange. And by strange, I mean very strange. I don't think I've ever done anything this way, but I have an idea. Let's see how this goes. So, if I want to bend half of it... Oh wait, that'd be so weird. I don't think that would work. Thinking. So, what I was gonna try to do was get this cut so that there's a center face here. That doesn't really work, does it? Because then once I bend it, then I have to restore that somehow, and it doesn't really work like that. Another thing I could do is have this initial extrusion, instead of being a boss extrude, be a swept extrusion. So if we had, let's say, started with a sketch here, I believe it starts at the bottom, so a line. Like that. So about, what is it, 2 inches? Wait, how long is this nail? 3 inches? 4 inches? Whoa. Hold on, so it's a 4-inch nail, and also Alphonse, thank you for the Twitch Prime sub. I really appreciate it. I'm glad that you're here with us. This should also be like 2 inches. And then we can fillet these. We can add a round like that, and then we'll just ignore the fact that that changes the length, because So what if we take this sketch? That's right. Take that sketch, sweep it across here. Yeah, yeet. That looks atrocious. And then we suppress this. Oh, but I can't. Delete that. Okay. Then it's gonna be weird. Oh, but I keep the sweep, and does this work? Wait, does the rest of it still work? Oh, I'm getting an error. I mean, that doesn't really matter, right? We can just keep going up. We can just, it's just a warning, right? This, we can just change the sketch plane and it should work. I think, like, if I just select that, then it didn't do anything, did it? Let's try that again. Alright, edit sketch plane. Boom. And then it should just be able to... Yay, we actually somewhat did it. That's pretty accurate, actually. Wow. I don't know what it doesn't like about this. It just doesn't like that there's a coincident there. I don't know what kind of funnel shape tool is this? I don't know what it's... I can't do anything with this tool. I can't select anything. What's with the funnel tool? What? I have no idea what this is. Like the purple pink thing. What time is it? It is 11:37. Oh, that's a nice number. Yeah, yeet. Okay, like, I don't understand. I can't even select this outer one. I can't constrain it. It just doesn't let me do anything. Do I have the right tool selected? No, I still can't do anything. I can only select stuff in my base model, which is not what I want. I'm in the sketch. Let's just try this. Solid Works pink funnel. Yeah, what is this? Filters, press F6. I don't think I've pressed F6, but okay. Thank you, forums. That is not the one I wanted. I should get that one. There we go. Now that one should be fully defined. And then on this bottom one, we'll just give it a quick old fix-a-rooney. Okay, but can I select this point, please? There we go. Those points are so hard to select, man. There we go. What could you possibly not like about this? It's a number. You want me to redefine it? I'll redefine it for you. Okay, what? Just do the thing, SolidWorks. Just dimension it. Oh my god. Please. Just dimension it. Oh, I'm so done with you, SolidWorks. Alright. It's fully defined, right? Are you happy now? Cool. Alright. There we go. Now we can import the bent models. They look pretty cool. What? I clicked on the I want this model. Wait, I want this one. There we go. I think the fact that it's transparent makes it weird. I don't like that. Well, it doesn't matter. We'll figure it out. So let's mate these. There we go. It actually like almost got it right. So let's drag this out and then mate this to this surface. Wow, that worked surprisingly well. Alright, and we'll duplicate this object. And then we'll mate this to the other side. The other alignment. And then this stop surface. Please, this surface. There. Boom. And then in the end, these two will probably be contacting. Oh, alignment. How do we do that? Oh, easy peasy. Can I select 3? No, 2. 2 mate entities. Okay. Not what I wanted. Not what I wanted at all, SolidWorks. Also, thank you, Alpha Does Life, for the follow on Twitch. Alright, we got this. So this one will probably work. Want this surface, and this. Yeah, there we go. Now it's all nice. Yeet. Alright. Alright. So now we can actually sort of build it. I need to change the material of the this core because I can't select it. It passes right through. That's really annoying. Can we select a new material? Something that isn't clear? Maybe ABS? Apply? Oh, that looks nice. I want this to look like that too. This stuff should also have that same material. I like that. Whatever that was, the ABS. That was good. Let's use that. There, that looks right. I'm not making mine out of ABS, they're PLA, but you get the point. So we can mate these two. I guess I didn't expect it to work right the first time. It's better. SolidWorks. Very intelligent. Oh boy. Alright. What's my special study? I am majoring in physics. No, I'm not. I lied. I don't know why I said I'm majoring in physics, because I'm not at all. I'm majoring in engineering, specifically aerospace, and what was the other one? Mechanical. I think it's looking good. Thanks, Tesla. Alright, so now we just kind of need holes in our board. So, I'm having one quick thought. Oh wait, is this already printing? Oh wait, it might be done. Hold on. It's not done, but it might be done like soon. Give me a sec. I'm gonna go check on it real quick. So it's building. It's not exactly the material I thought it was. I forgot to change the material. It's a bluish one. I wanted the same white one. So I'll probably just do a quick test on that one. And I want to modify the design for the second print. Do I play piano on a real piano? I do sometimes. When I have time. I like to. So I have an idea. Let's sketch on the front plane. And let's cover up half of it. Let's glue it in so there's less wiggle. How do we go about that? A good question. It doesn't really matter which way we have it, does it? Probably cover up that side. Oh, let me do something first of all. This split, select that other half so that we have this half to work with, which is the correct orientation half. Because the way SolidWorks exports stuff is stupid. And then we can build an arc that is a rectangle. We can build an arc. Chunk, and doop. And then we draw a line. Up. Alright, so basically this goes... Wait, what? What did I select? I want that and that. And that should be co-radial. And then this is gonna be like... There's no like quadrant on the here. There's a quadrant on this one though. So if I drag it back, then it should give me a quadrant on this circle right there. It should. It doesn't. Alright. Oh, you're right. I don't play on a real piano. I play on a keyboard. Where the copper wire is gonna wrap around? This. Just that. So where they're gonna wrap around. Oh, I can use the plane, right? Does that count? That works, sure. We'll do that. Extrude boss. Sure, and then we're gonna boss to here. There. Wait, that's too much. It shouldn't go all the way there. I need some clearance. So there are two. These pieces are a total of 3 inches apart. So where's my nail? These are bent in half. So, and the plastic is 1.5 inches, which means it has to extend about half an inch into the next one, into the next piece. So it's gonna look something. If I can edit this. Offset 0.5 inches that far in, so that nail has room. There. And we can actually check that, because, you know, why not? So let's skip the mirror every feature. I believe we can just mirror the body. There we go. So that looks pretty wonky. Oh, that's not what we want though. That is almost what we want. We want it mirrored, but flipped. So we actually want it like duplicated. So it's kind of a weird mirror. So we want it mirrored, but not like mirrored. We really want it to be duplicated. And so mirror, rotate. Oh wait, right. Linear, circular pattern. That's what we should do. What graphics card do I have? I have a GTX 1080 Ti. What parts is the rotor and which one is the stator? I will show you in just a second. I use different terminology, but I'm sure we can work it out. Just give me just a sec. I actually need to draw in a line for it to rotate about, so let's draw a center line from there to there. Perfect. Perfect. Alright, now we can make a circular pattern of equidistance 2, and then direction around here, body, the entire thing. Hey, it worked. Is there a way to merge them? Because I would like to do that. Okay, it just seems to have a disjoint in it. SolidWorks, circular pattern, merge, bodies. Oh, there should be a combine. Is that true? Combine. Yee, that's what we wanted. Alright, so that's what we want our part to look like, and this is how we want our part to print. So we'll save this as the STL. Wait. Oh, wait. I think I selected the wrong option. So save as. For the new file, save copy. Yeah, that's what we want. Do I need that powerful graphics card for 3D modeling? Absolutely not. No, not at all. Look at that mesh. All right. Give me just a sec. We'll pull this in. And now mates are broken, because why not? So this we can hide. We broke some stuff. Tangent. Parallel. Oh, okay. So that face got a little messed up. That's okay. We'll make these. And then these should be parallel. Alright, and then this doesn't move, I guess. Oh, I see, because I pretty much flipped it around. That's why those mates didn't exist anymore. Can you see everything? I don't know. Can you see everything? You'd be like a psychic, wouldn't you? But this is everything. An elegant solution, I must say. Although keep in mind that there's going to be stuff wrapped around here, so that won't really be touching the wood, because there's going to be copper coiling around it. But that part's less important. I believe there's a way for me to do a special sort of mate. Yeah, an advanced mate with the width. Look at how pretty that is. And then, no, don't do that. All right. Advanced mate width. So width selection, and then our tab's gonna be this. Wow, that actually worked. I'm surprised. So now this should be fixed. Exactly what we want, yes. Okay, so now, here's the question. Oh wait, actually we don't need to do anything like that. I was wrong. So we can just select width here and here, and our tab to be this cylinder. One more width here, our tab. Can I select a point? Probably not, right? Okay, yeah, that's it's not quite what I had in mind. Whoops. All right, let's get back out of there. Wah. Okay, so it seems to be rotating. It's good, right? Where is that nail? Where the motor is? Where is it connecting? I'll show you. Just give me a sec. All right. Mate. One more big idea here. Let's do a width, and what if we do this sort of constraint, and then our tab is that one. Oh, it worked. I'm moderately surprised. Okay, now it only wiggles back and forth like that. Well, it has to be centered here. I know that, so we have just one more easy tabbed width to make, so. I can't select those. Wait, oh, I can select these. Ha ha ha. Ha 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 ha. Totally meant for that to happen. And then we can just select the core. There, and then it rotates like that. And it runs into the nails. Well, that's not supposed to happen, but... Maybe I should extend the electromagnetic core just a little bit, because I kinda a little bit forgot to account for this. That's 2.7. Oh, and the heads of the nails are longer than... Okay. You watch Real Engineering, are you a professional? I don't know, are you? You tell me. Alright, so this... I had it at 2.85, but I think I need to turn it up to 2.9 again. Alright, and now everything should rebuild nicely. It didn't, really. Maybe I should have this be 3 inches? Can I edit this from here? Yes, I can. Oh boy. Alright, let's have that be 3 inches. And hit OK. I can't tell. It almost looks better. Wait. Oh, it is better. It is better, yeah. It like barely doesn't touch. That's good. Keep in mind of your rotor circumference and stator length to avoid excessive resistance. So here's the plan. This is the rotary thing, and this is the magnety thing. So whatever those words mean to you, I'm sure Now this is where the transparent material would be a little helpful. What's that? Is that hide the part? Okay, material. Let's select that like clear one. I want to see inside. Oh wow, look at that. Oh looky. It's pretty inside. Look at how perfectly that fits. I guess it doesn't fit perfectly, but like it fits and it's pretty. All right, so we have that. Now I will need to drill holes into the wood to facilitate the zip ties. But that should be easy, and the tolerance probably doesn't matter that much. Aside from that, I'll need to somehow affix or hold up bearings. So we'll figure out something for that. But I think we're pretty set, I think. This is roughly what it's gonna be looking like, you know? Rotating like that way or this way. I don't know which way. I guess we'll find out. Oh yeah, so this is the rotor, this is the stator. It's gonna have wires. So the way I understand how the wiring works, I have a diagram here. So it goes, we have a power source and we can start positive, negative. Let's say we start positive, so we are going in the direction of current. We go here, we're winding around this stator or the electromagnet, and that's going to basically make this end north and this end south. Then this wire comes back, connects here, and it's going to have a brush which contacts the commutator and changes polarity when it rotates. So it changes the polarity of the magnetic field when it rotates,